Now, let's look at case number 3, wherein the object A is in initial velocity. Again, so if we're going to look at case number 3 here, the object A is moving with an initial velocity, and object B is not moving. So this one is at rest. And then, after a collision, what will going to happen? Object A and object B join together. They stick and moving together with the same velocity. Okay? And so, let's try to look now on the case for problem number 1 of case 3. An 85 kilogram fisherman jumps from a dock into a 135 kilogram rowboat at rest on the west side of the dock. If the velocity of fisherman is 0.30 meters per second to the west as he leaves the dock, what is the final velocity of the fisherman and the boat? And of course, we're going to have our given here. The given would be an mass 1. It would be a mass 1 wherein the man is 85 kilograms with an initial velocity of 4.30 meters per second. And so he jumps to the boat, okay, or he jumps onto a dock, rowboat, wherein initially that rowboat is 135 kilograms, and the initial velocity is at rest, so that would be 0 meters per second. And then, if you can imagine here, just like the man, so he jumps on the dock, and after he jumps, what happens here is that, of course, the man and the boat will gonna move. And so what will be the required here? The required is the final velocity of both the dock and the man. And if we're gonna look at our scenario, this would be the scenario, right? That would be the scenario. And so we could have now our equation, which is mass 1 v1. So we have here the momentum equation, mass 2 v2 is equals to mass 1 v1 plus mass 2 v2. So this one is the momentum equation. And of course, there's an option that if we could write here the initial conditions. So we have the initial, and then we have the final condition. And so if we're going to look for the mass 1, that would be 85 kilograms. So we're going to plot it now. So 85 kilograms multiplied to the velocity is of 4.30 meters per second, plus the mass 2 and the V2I. Take note that this one will be cancelled, because even though if we're going to write it like 135 kilograms, and then the V2, that would be 0 meters per second, that would be at rest, so this one will be cancelled. And then the M1, we're going to be joined together. We're going to have now the 85 kilograms multiplied to V final, which is we don't know. Anyway, they're just going to have the same velocity, so we can represent it with VF plus 135 kilogram for the boat, and then since they join together, we have the VF. And so notice here that we could simplify that as 85 multiplied to 4.30, and then we could factor out the VF, so we have 85 kilograms plus 135 factoring out the VF, and so this is now our working equation. And so we have 85 times 4.30, that would be 365.5 kilogram times meter per second. And we have your 85 plus 135, that would be 220 VF. And so working now, we have 365.5, divide both sides by 220. And VF now here would be 1.66 meters per second. Now you might be wondering on our units how it becomes meters per second. So take note that this one is in kilogram times meters per second. So this one is in kilogram, right? And so this one is in kilogram times meters per second. And so the 220 here is in kilograms, so we might cancel out the kilograms. So we might be helpful to know that are required would be the VF, and the unit for that would be meters per second. Now notice here that on this problem, we can solve for the velocity, and I want you to look that on solving the velocity, we already have the momentum formula, and if we are asked for the energy conditions, we're going to use the kinetic energy formula.